Hi there, this is a very quick video just to explain the problem with beta radiation within the quantum world, or the issue that was exposed by it. So first of all, just remember that if we look at alpha radiation has some really clear, distinct energy levels. And this indicates that the nucleus has distinct energy levels of which discrete amounts of energy are released, as shown by alpha particles and the emission energies. Now, unfortunately, beta radiation didn't follow this pattern in any way at all. This was a major stumbling block. How could it be explained that in a quantum world there's a continuous emission spectrum? It kind of fell apart a little bit. Now, there was obviously an explanation for this. The explanation for this is the recognition that with beta radiation, as well as beta radiation being given off, there's also a neutrino. And neutrinos of different energies compensate. So if we combine the energy of the beta radiation and the neutrino, then it would reflect more effectively a quantum world. So suddenly the beta issue is no more. It gives me a chance just to remind you though about beta radiation, so let's go over the basics here. So beta radiation, we've got to remember, is basic beta decay is going to have a high energy electron emitted. So a neutron in the nucleus changes into a proton and a high energy electron, which is obviously emitted plus a neutrino. An example of this decay would be from going from carbon to nitrogen. And the effect is that the atomic mass stays the same, but the atomic number increases by 1. Now that's straightforward beta decay of high energy electron. We must remember, and this is an important kind of an addition, that there's a second type of beta decay, and that's beta decay where there's a high energy positron emitted. What happens in this situation, a proton in the nucleus decays into a neutron, and a high energy positron is emitted plus a neutrino. So again, the atomic mass stays the same, but in this case the atomic number decreases, and here I've got an example of carbon turning to boron with the release of the beta plus and the neutrino. So that's my quick recap on beta radiation and identifying the problem or the trouble with beta.